In this problem, you want to determine how many years it will be before you've made a total of $1,025,000. If you start with $37,000 a year in salary and there's a raise of $1,500 per year every year. So what you can do to try to figure out how to solve this problem is start by just looking at what happens in year 1, year 2, year 3, and so on. Looking at just the first 3 years, we have a starting salary of $37,000. Then there's an increase of $1,500, so the second year you're making $38,500. And then in the third year, we've got the $37,000, the original, plus the raise from the previous year, plus the current raise, and that brings you up to $40,000. So this is an arithmetic sequence, and I can write the formula for the nth term of the sequence because that's what we want to, well, eventually that's what we're going to need in order to find the total salary of $1,025,000. All right, so my formula for the sequence is A sub n equals the initial amount plus that common difference, which is the $1,500 raise, times n minus 1. And we can see why it has to be n minus 1 here, because we don't have an additional $1,500 the first year. It comes in the second year, then there's 2 in the third year, there'll be 3 in the fourth year, and so on and so forth, added to the initial salary. So that's why we have n minus 1 instead of n. All right, so we want to know how long it will be until we have a total salary of $1,025,000, because it's going to take an awful long time to be making $1,025,000 if you're starting at $37,000 a year with a $1,500 raise every year. So what we need is the sum. And the sum formula, and this is for the first n terms, because that's what we're really trying to find out. How many years will it be? So the question is, what's the value of n? And our formula for the sum of the first n terms of an arithmetic sequence is a sub 1 plus a sub n divided by 2, and then we multiply that by n, the number of years in this case. And we know that this is going to be $1,025,000. So now what I can do is I can take this expression and plug it in for a sub n, and then I just have a variable of n to solve for. I'm going to start with a clean page to do that. Okay, so a sub 1 is the 37,000. And then we're going to add to that the last term, a sub n, which is 37,000 plus our common difference 1,500 times n minus 1. And all of this gets divided by 2, and then we multiply by n. And that should equal $1,025,000. So now I'll just solve for n. This is a quadratic equation. And let's see, we've got 37,000 plus 37,000, and that will give me 74,000 plus 1,500n minus 1,500. And we have that all divided by 2, and then times n. And that equals the 1,025,000. Okay, I'm going to multiply both sides by 2 just to get rid of that fraction. And I can combine together the 74,000 and the 1,500, so that'll give me 72.5 plus 1,500 n, and this is times n, and that's going to equal $2,050,000. Distribute the n, and I've got 1,500 n squared plus 72,500 n, and I'll bring the 2,050,000 over. And then that all equals 0. Before I solve this quadratic equation, and I can do that using the quadratic formula, I'm going to divide all of the terms by 500 because it goes in evenly, and then I'll have smaller numbers to work with. Okay, so now we have 3n squared plus 145n minus 4,100 equals 0, and I'll use the quadratic formula to solve. So I get n equals negative b plus or minus square root of b squared minus 4 times a times c, and that's all over 2 times a. So this will work out to negative 145 plus or minus the square root of 70,225. That's over 6. And this should be a negative 4,100, not positive. So there you go. And let's see. So we get negative 145 plus or minus 265. That's all over 6. And it can't be negative 145 minus 265 because we know we need a positive answer. So we'll take 265 minus 145, and that gives me 120 divided by 6, which is 20. So it'll take 20 years to make a total salary of $1,025,000.